This is the lathe. It spins your part so you can cut it down to the right size that you want. The electric motor spins at a variable rate, faster for lighter, for softer metals, so that you can get your job done faster, and slower for harder metals, so that there's less stress on the cutting tool.
All right, the lathe consists of an electric motor which powers the spin. Your tool, your cutting bit, held by the tool holder, which slots into the machine, like so. And it's moved around with 2 dimensions of freedom, so it can go forward and side to side, and also has a diagonal direction for diagonal cuts. All right, and before you start, as we mentioned, you need to use a lower speed for harder metals. So right now it's set on the middle diameter, which at the low gear translates to 160 RPM, which is about right for our mid-level steel. Okay, to get everything set up, what we're going to do is we're going to place a little center dot on the center of the part, such that we can align the tool bit so that it's perfectly at the middle of the part, which will give us a good clean cut. So to do that, we're going to turn it on. I'm just going to move in the centering tool. Just touches. Right there. And that's all we need. Then we'll bring in our cutting tool and just make sure it is well aligned with the center. Now if you don't get it centered properly, it will give you an unclean cut. It'll look very rough, and there'll be a sort of defining pattern to it, which you'll notice. Make sure that gets really tight, because it will be metal pressing up against metal, so it'll endure a lot of stress. Alright, and now we're ready to cut. So let's go. Currently, our part is 1 1/4 inches wide, and we want to cut that down to a 1/2 inch in diameter for the thinner part. And that thin section is going to extend for 1 1/8 inch of the end of the part. So go ahead and get started. You use a very slow and steady turn of the wheel to cut the part, especially at the beginning when you're not sure if it's going to get too hot or if you've cut too deep. You don't want to cut too deep because it'll put too much strain on your tool holder here and can actually break your cutting tool. You can use the dial indicator to, let's see, zero it out here, and then add 0.10 of an inch, and then begin cutting back. Real smooth motion. Be careful. We made our first cut. To improve the quality of the cut, you can use an air hose blowing on it while you're cutting to keep it cool, or some cutting fluid, which will accomplish the same end but better.
Okay.
Now that we've cut down the thin side to the requisite diameter, we will remove it, and we do that by placing this in here, turning it just to release the grips, and we're going to turn it around and grip on the small side so that we can trim down the larger diameter surface, which is currently, you can see, at 1 1/4 inches. And we're going to trim that down to 1 1/8 inches. So that hasn't changed, so we can go ahead and get going.
like penetrating my brain.
Once you get the requisite diameter, you can check with a ruler or a pair of calipers. You're going to want to take a piece of sandpaper and just hold it up against the part. It'll get a little hot, so you can pull it away, just cool it a little bit. And you're just removing all the little burrs and little dents and indentations you might find, so you get a good, clean finish. And now we're ready for our segment entitled Alright, set up the part like so. We've got the thin diameter back on the outside, and we're ready to put a knurl pattern on it. The knurl pattern is used to give it grip, like you would find on the handle of a tool. We're going to get started. We've aligned the knurling tool similar to the cutting tool, and it's just that it's perpendicular to the part, and it's got to be dead on, so it's perpendicular to the long axis of the part and parallel here. Okay. Move it in and basically just throw it onto the part until the two little knurling wheels start. Bring it over.
And this is the finished knurl pattern on the widget.